March 19, 2026. Iranian state media released footage that American strategic planners hoped they would never see. The Bavar-373 air defense system, Iran's domestically produced long-range surface-to-air missile platform, went fully operational at 3 separate locations across Iranian territory. Not a test deployment, not a training exercise, full operational capability with live missiles, active radars, and crews on 24-hour alert status. The footage showed missile launchers in firing position, radar arrays scanning the skies in real time, and Iranian air defense officers monitoring screens displaying tracks of aircraft hundreds of kilometers away. Western intelligence agencies confirmed the deployment within hours. Satellite imagery showed the distinctive radar configurations at all 3 sites. Electronic intelligence detected the systems actively scanning. The Bavar-373 wasn't just operational, it was already tracking aircraft over Iraq, Syria, and the Persian Gulf. Every American military flight within 300 kilometers of Iranian airspace was now visible on Iranian screens. And here's the technical detail that should make every B-2 pilot reconsider their mission briefs. The Bavar-373 operates on the same VHF and L-band radar frequencies that already proved capable of tracking F-35 stealth fighters when Russia delivered the S-400 to Iran last month. But the Bavar-373 isn't just a copy of Russian technology. It's an integrated system specifically designed to exploit the exact weaknesses in American stealth aircraft that Russian engineers identified and Iranian technicians spent a decade learning to target. The Bavar-373, NATO reporting name not yet assigned because Western intelligence didn't believe Iran could actually build it. Maximum engagement range, 300 kilometers. That's 186 miles. Engagement altitude, 27 kilometers, roughly 90,000 feet. Missile speed, Mach 4.5. And unlike the S-400, which Russia controls through satellite data feeds and software updates, the Bavar-373 is entirely Iranian. Iranian radars, Iranian missiles, Iranian command and control. Iranian software that cannot be remotely disabled if Moscow decides Iranian operations are becoming inconvenient for Russian interests. Iran just achieved technological independence in the one domain that matters most for countering American air power. They can now track, target, and engage American stealth aircraft without requiring permission, support, or data feeds from anyone. The Bavar-373 consists of 4 primary components: the Mirage 4 surveillance radar, a VHF band early warning system with 450-kilometer range against conventional aircraft and 200 kilometers against stealth targets, the Bashir fire control radar for missile guidance, the Sayed-4 interceptor missile, 2-stage solid fuel with 27-kilometer altitude ceiling, and the Sayed-4B variant, 300-kilometer range, optimized for reduced radar cross-sections. The Mirage 4 operates at VHF wavelengths between 1 and 10 meters, where stealth shaping becomes ineffective. And the B-2 was designed for invisibility against X-band radars using centimeter wavelengths. At VHF frequencies, the B-2 surfaces reflect enough energy to generate trackable returns from 200 kilometers away. American stealth doctrine assumed that even if VHF radars detected a stealth aircraft, they lacked the precision to guide missiles. That assumption was correct in 1995. It's not correct in 2026. Modern digital signal processing allows VHF radars to achieve targeting accuracy that was impossible with analog systems. The Mirage 4 can track a B-2 with enough precision to hand off targeting data to the Bashir fire control radar, which then uses S-band frequencies to refine the track and guide Sayed-4 missiles into terminal engagement range. Once the missile gets within 20 kilometers, its own active radar seeker goes active, and at that point, stealth becomes irrelevant because the missile is close enough that even a reduced radar cross-section provides a clear return. 3 Bavar-373 batteries are now operational in Iran. 1 positioned near Natanz, protecting Iran's uranium enrichment facilities. 1 near Isfahan, covering Iran's nuclear research centers. 1 near Bushehr, defending Iran's only operational nuclear reactor. The positioning is not accidental. These are the 3 sites that American strategic planners identified as primary targets in any scenario where the United States decides to strike Iranian nuclear infrastructure. And now all 3 sites sit inside overlapping coverage zones of an air defense system, specifically designed to kill the aircraft the United States would use for those strikes. The coverage geometry creates a defensive umbrella that extends from the Zagros Mountains to the Persian Gulf coast. Any strike route toward Natanz passes through at least 2 engagement zones. Isfahan is covered by 3 overlapping radars. There is no approach vector that avoids detection. There is no altitude that remains outside engagement range. The defensive network just eliminated every penetration corridor American mission planners spent 15 years mapping. The B-2 Spirit bomber is the only American aircraft capable of carrying the GBU-57 massive ordnance penetrator, the 30,000-pound bunker buster bomb designed to destroy deeply buried facilities like the ones at Natanz and Isfahan. The United States operates 20 B-2 bombers, Each one costs $2.2 billion. Losing even one aircraft to Iranian air defenses would be the single most expensive combat loss in American military history. Losing two would be a strategic catastrophe that calls into question the survivability of the entire American stealth bomber fleet. The calculus for American mission planners just changed from high risk to potentially unacceptable. Because the aircraft you need to strike Iranian nuclear sites are now visible to the systems defending those sites. Iran didn't build the Bavar-373 in isolation. The system's development began in 2010 after Russia refused to deliver S-300 air defense systems Iran had already purchased. That refusal, driven by American and Israeli pressure on Moscow, forced Iran to develop domestic alternatives. Iranian engineers studied Russian S-300 and S-400 technology through Chinese intermediaries who operate both systems. They analyzed American stealth aircraft radar signatures collected by Syrian air defense networks during Israeli strikes. They reverse-engineered components from downed American drones, particularly the RQ-120 Sentinel stealth UAV that Iran captured intact in 2011. That single drone capture gave Iranian engineers access to American stealth materials, coding compositions, and design principles that informed every aspect of the Bavar-373's development. They spent a decade testing different radar frequencies against RQ-170 components to determine which wavelengths defeated stealth most effectively. The answer was VHF, and they spent another decade integrating all of that knowledge into a system optimized for one specific mission, tracking and killing American stealth aircraft that used the same design principles as the RQ-170. The result is not a copy of Russian technology, it's an evolution. The Bavar-373 incorporates lessons learned from watching how American stealth aircraft operate in combat, something Russia's export systems weren't designed around. Iranian engineers know exactly how Israeli F-35s approach their targets, because they've been tracking them for months using Russian-supplied S-400 radars. They know the altitudes stealth aircraft prefer, the approach vectors they use, the tactics they employ to minimize radar exposure. They know Israeli pilots favor ingress routes through Syrian airspace, where coverage was historically weak. They know F-35s typically operate between 35,000 and 45,000 feet during penetration phases. They know the aircraft descend to 25,000 feet for weapons release to improve targeting accuracy. All of that operational intelligence got built into Bavar-373's engagement algorithms. The system doesn't just detect stealth aircraft. It predicts their behavior based on observed patterns and positions interceptors along the most likely flight paths before the aircraft even enter Iranian airspace. Here's what happens when a B-2 approaches Iranian airspace targeting Natanz. The bomber flies from Diego Garcia, 2,400 miles, penetrates at high altitude to maximize the GBU-57's velocity, releases from 40,000 feet. The Mirage 4 detects the B-2 at 200 kilometers, roughly 15 minutes out at cruising speed. Iranian air defense classifies it as a stealth bomber. The Bavar-373 battery goes to full alert. At 150 kilometers, the Bashir achieves lock. The B-2 has no warning, no radar receivers for VHF frequencies. At 100 kilometers, Iranian air defense launches two Sayed-4B missiles. Flight time, 3 minutes. The missiles climb to 25 kilometers, accelerate to Mach 4.5. At 40 kilometers, their active seekers go hot. Now the B-2's warning receiver finally detects the threat. The crew has 45 seconds to react. But the B-2 was never designed for defensive maneuvering. Subsonic, limited turn rate, no afterburner. The defensive options are non-existent. The missiles close. Terminal guidance is radar-based. Chaff is useless because the missiles discriminate between aircraft and decoys. One missile detonates within lethal radius. Fragmentation warhead shreds the B-2's control surfaces. Hydraulic pressure drops to zero. Flight control authority degrades catastrophically. The flying wing design that made the aircraft stealthy now makes it uncontrollable when damaged. The crew initiates ejection sequence if systems remain responsive. The bomber, $2.2 billion in taxpayer money, impacts Iranian desert 90 kilometers short of target. Natanz remains intact. The GBU-57 never releases. American strategic bombing doctrine just suffered its first stealth loss to a regional power air defense system. The missiles close. Terminal guidance is radar-based, meaning chaff is ineffective because the missiles can discriminate between the aircraft and the decoys. One missile detonates within lethal radius. Fragmentation warhead, designed specifically to shred aircraft control surfaces. The B-2 loses hydraulic pressure, flight control authority degrades, and the aircraft becomes unflyable. The crew ejects if they have time. The bomber, worth $2.2 billion, crashes into the Iranian desert 90 kilometers short of its target. The mission fails. The weapon never releases. Natanz remains intact. An American strategic bombing doctrine just suffered its first stealth aircraft loss to a non-superpower air defense system. That scenario is not hypothetical. It's the inevitable outcome of flying a 1980s-era stealth bomber against a 2020s-era air defense network specifically designed to defeat it. And American military planners know it, which is why missions into Iranian airspace just became unacceptably risky. The United States cannot afford to lose B-2 bombers, not financially, not strategically, not politically. Each loss would be a propaganda victory for Iran that demonstrates American technological superiority as a myth. Each loss would embolden every adversary watching to invest in similar systems. Each loss would force the United States to explain to allies why the most expensive bomber program in history cannot penetrate the defenses of a regional power. And each loss removes one aircraft from a fleet that only has 20 operational bombers total. Lose 3 B-2s to Iranian air defenses, and the entire strategic bombing capability against hardened targets drops 15% permanently. There are no replacements. Production ended in 2000. The Bavar-373's operational activation creates a strategic problem that has no good solutions. American doctrine for striking hardened underground facilities requires the GBU-57 penetrator bomb. Only the B-2 can carry it. If the B-2 cannot safely penetrate Iranian airspace, the GBU-57 cannot be delivered. If the GBU-57 cannot be delivered, deeply buried sites like Natanz cannot be destroyed. And if Natanz cannot be destroyed, the military option for preventing Iranian nuclear weapons development effectively ceases to exist. The alternatives are all worse than the problem. Cruise missiles like the Tomahawk cannot penetrate deeply enough to destroy buried facilities. Conventional bombs dropped by F-35s or F-15s lack the mass and velocity to reach targets 60 meters underground. Tactical nuclear weapons would achieve the destruction, but trigger international condemnation and potential nuclear retaliation. The GBU-57 delivered by B-2 was the only option that combined sufficient penetration capability with political acceptability. The Bavar-373 just made that option unavailable. Iran's development signals a broader shift. Regional powers are achieving near-peer capabilities in specific domains without superpower resources. Iran's defense budget is $25 billion annually, 3% of America's. Yet Iran developed an air defense system threatening bombers that cost 100 times Iran's entire annual budget to develop. That asymmetry results from focused investment in a specific problem rather than matching American capabilities across all domains. Other countries are watching. North Korea, Syria, any nation with technical expertise can follow Iran's model. The technological monopoly. American stealth, represented for 30 years, is ending because adversaries built better detection systems. China applies the same logic with anti-ship missiles against carriers. Russia prioritized air defense over stealth aircraft production. All validate the same principle Iran just proved. Exploit American weaknesses with focused investment rather than achieving overall parity. Developing counters to VHF air defense requires redesigning stealth aircraft from scratch, decades and hundreds of billions of dollars, or shifting to standoff weapons that cannot reach buried targets. The physics of penetration require high-velocity impact, proximity to target, aircraft penetration. The B-2 cannot safely penetrate Iranian airspace anymore. The likely American response involves electronic warfare systems to jam VHF radars, but that faces limitations. VHF wavelengths require physically large jamming antennas, larger than most aircraft carry. Even successful jamming only degrades range, doesn't eliminate tracking. Iranian operators compensate using multiple radars, cross-referenced through multilateration. Extremely difficult to defeat. Iran developed this system under comprehensive sanctions, cut off from Western technology, denied advanced components, facing active sabotage. Iranian engineers still built a system threatening America's most advanced aircraft. That outcome means sanctions alone cannot prevent technological proliferation. March 19, 2026. The Bavar-373 went operational. American B-2 bombers became visible from Tehran. And the strike option that American presidents relied on for 3 decades just became unavailable. Not because Iran won a war, because Iran built a system that changed the mathematics of air defense in ways that American stealth technology cannot overcome. The stealth bombers are still flying. The missions are still being planned. Training sorties continue. Briefings happen. Commanders review target folders. But everyone involved knows the truth that official statements won't acknowledge. The aircraft that were supposed to be invisible are now being tracked in real time by systems designed specifically to kill them. American mission planners sit in windowless rooms at Strategic Command staring at the same impossible problem. Every strike option against Iranian nuclear facilities requires B-2 penetration. Every B-2 penetration route now passes through Bavar-373 coverage zones. Every coverage zone represents an unacceptable loss probability. The mathematics are simple and brutal. The mission cannot be flown at acceptable risk levels. The target cannot be destroyed without flying the mission. And there is no operational adjustment, no tactical evolution, no technological countermeasure that restores the advantage that no longer exists. The Bavar-373 is active. The radars are scanning. And every American stealth bomber within 300 kilometers of Iranian airspace is visible, trackable, and targetable by a country that just proved sanctions cannot stop technological development when survival depends on it.